Nama saya Eddie daripada Singapura. Saya Eddie Special, EDDIE, bukan EDDY. Okay, yeah. So Eddie daripada Singapura, EDDIE, tak EDDY. Okay, saya seorang manager aplikasi TI. Saya bekerja di TI telah 20 tahun. Okay, saya tak cakap bahasa Indonesia. So I shall do my presentation in English instead. Okay, yeah. All right. So for the first session, I shall talk about the overview of TI's embedded processing products. Okay, and this is if you know that TI, we have a long history from DSP, digital signal processing, and now we call it embedded processor. So for TI, we have a very wide variety of embedded processor products. Just remember, very simple, from 20 cents to 2 gigahertz. Okay, 20 cents to 2 gigahertz. So our portfolio can be very simple, low-cost MCU for your housekeeping, I/O function, expansion, I2C, SPI, or we can do AI, Edge AI with 2 gigahertz processing capability. And not only that, okay, you know that TI, we are not just a digital company. We are actually very strong in analog. All right, so our microcontroller come with the best-in-class analog on the MCU. Okay, and you know today when you buy the MCU, it's not just the ARM M0 that you're buying. You're buying the ADC, PWM, timer, a lot of other features. Okay, which is TI is very strong in. All right, and we have a whole suite of software that you can reuse across the TI products and portfolio. And we also have tools to enable you to do AI. Okay, and TI, one thing special about TI is that we manufacture our IC chips by ourselves. Okay, we are 80% in-house manufacturing. We are not a fabless company. TI, we are design, manufacture, and sell semiconductor. Okay, so we have our own wafer fab, and our digital products comes mainly from this fab called L-Fab, which is in Lehi, in Utah. Okay, so TI, you know, most of our factories are in Texas, but our digital one is in Utah, not Texas. All right, so we do 45 nanometer to 65 nanometer. Okay, and you may ask, like, well, NVIDIA is doing 2 nanometer, 3 nanometer. So why is TI doing 45 nanometer, not catching up? Okay, so let me ask you, for microcontroller, 20 cents, do you need 2 nanometer? Don't need. Okay, so that's why 45 nanometer to 65 nanometer is the sweet spot for microcontrollers, Bluetooth, Wi-Fi, okay, where about 30% of the IC or less is digital, and 70% or more is analog, okay, for microcontrollers. Only if you do a FPGA or GPU, then yeah, you are looking about 2 nanometers, 3 nanometer technology. So TI, we are focused on the 45 nanometer process nodes to 65 nanometers for digital products. Okay. Yeah. Oh, sorry, the screen is not synchronized just now. Sorry about the mistake there. Yeah, okay. Okay, so when it comes to the process nodes, TI is 65 nanometers and 45 nanometers, and we are going to 28 nanometers next. All right, so that's the next process we are going to. When we talk about Bluetooth, Wi-Fi, we want to go for a little bit lower power supply. We go for 28 nanometers. Still, we do not need 2 or 3 nanometer. But there are some products that we need 16 nanometers and below, and that's our 1 gigahertz and 2 gigahertz processors. Okay, so on those processors where we do Edge AI, okay, such as auto parking for a car, okay, or some failure analysis of equipment, okay, AI analysis of equipment, okay, we will run our 16 nanometer process on TSMC, and we also have our 8 nanometer process with Samsung Korea, okay, and we're also working with our partners for the 5 nanometer process. So these are from 5 nanometer to 16 nanometer, TI we will outsource. That's the 10 to 20% that we outsource, but all the rest we will do in-house. And in terms of processor, ARM Cortex processor, we are doing the A8, A15, okay? And then the next product is the A53 and A72. And the next gen, we're going to do the A35 for low cost, A520 and A720 for high performance. And in terms of microcontroller, we have the M3, M0, which you are very familiar with already. We are already doing our M4 and R5F microcontrollers. And next gen, we're going to do the M55, M85, and R52. Okay? And not forgetting DSP. Some of you may be old enough to remember TI DSP. We have the C6000 DSP, right? But we also moved on to C7000 DSP. We took quite a while to come to C7000. The key difference is, last time all the processors are 32-bit, right? C6000 are 32-bit processor. So now ARM is 64-bit. So TI DSP, we also do 64-bit. So C7000 is our 64-bit DSP, okay? And TI is a company that you can depend on for geopolitically dependable capacity. Now, the big topic that everybody talk about is tariffs. Okay, the tariff, they ask me how and what. I will tell you that every day it changes. Okay, every time the president talk, the rule change for tariffs. Suddenly have tariffs, suddenly don't have tariffs. But whatever it is, TI, we are ready. Okay, because first of all, we are always invested in the US. Okay, so our wafer fab is almost all in US. Okay, in Texas, in Utah, we have a lot of wafer fabs in US, and that is exempt from a lot of tariff constraints. Okay, if you follow the news recently, Apple announced that they have a $600 billion investment plan to do the American manufactured companies. Right, TI is one of their partners. Okay, because we have so much wafer fab in US that we can support Apple and also many other customers in the world to have their supply chain in the US. Okay. And not just wafer fab. Okay, we have so much wafer fab. Then what happened about the assembly and test, right? The IC packaging, lid frame, molding. We also expand, okay, in Malacca and Kuala Lumpur. Okay, and we can expand very fast in these two countries because in these two sites, because we already have a Malacca and a Kuala Lumpur factory. We just expand next to the factory. Okay, so that's how we can expand very fast in our capacity. So with that, you can be assured that when the next upturn cycle comes, when you face shortages, TI is ready to supply you. Okay, TI is ready to supply you, then overcome the shortages, be it for market surge or be it for tariffs and political reasons. Okay, let's talk about the product. Okay, so TI processors. Let's start with the highest tier processor first. Okay, TI is our new generation of processors. Now it's called the AM6 series. Okay, we call it the Citara series. Okay. You may be familiar with the AM335X, okay? It was very popular about 10 years ago for a lot of applications, okay? So that was the product that we had at the bottom left of the screen. That's the AM335X, which is an ARM Cortex-A8 at 1 gigahertz. And in that family, we actually scale up to the mid-tier, which is the AM62L. So we're talking about low-cost processor. Okay, you're talking about less than $10 processor, AM335X, and AM62L. But if you need more performance, okay, you can move up to the AM62P or the AM67. So, for example, on the AM67, what we offer is 4 times ARM Cortex-A53, 1 housekeeping MCU, which is ARM Cortex-R5F. We have 3 display interfaces, 50 gigaflops of operating, okay, of processing, all right? And we also do the 4K video encode decode at 30 frames per second, USB 3, PCIe. Okay, so these are how scalable we are in TI, from low cost to high performance. Okay, within the general purpose. And if you are not just doing general purpose display I/O, you want to do processing, signal processing. Maybe you want to do some radar processing, video processing, or some AI processing. Then you go to our HAI or Signal and Analytics series. Okay, so very simple from TI. If you see a A behind, means AI. You see a D behind, means DSP. Okay, so 67A and 67D. Okay, it's our AI and DSP version of our processor class. Okay, so what we do when we put the 67A, we have one more additional processor there to do the AI acceleration. Okay, so you can do your neural networks calculations in that special hardware to accelerate your AI processing. Okay. And then the DSP is the traditional DSP for customers who want to program at DSP level, right? Maybe your audio processing, video processing, you want to use the DSP. So there'll be a D series. Also, we have this group called the networking. Okay, there are some customers, especially in our factory automation, like you do a PLC controller, backplane equipment that you hook up to the factory equipment. These customers, they want gigabit Ethernet, but they don't want Linux. They don't want 1 gigahertz performance. They just want high-speed interface, but 100 megahertz, 300 megahertz MCU is enough. So we have the AM243 as well as AM64. Okay, so we provide you with gigabit Ethernet, dual port, okay, to do your Etherring, okay, do your EtherCAT, Ethernet IP, and then we give you a simple MCU to run your simple applications. So with that, you don't have to overpay for a very high performance chip. You can buy a lower cost device, very good networking, but simple processing. So with that, TI will cover a very broad portfolio of products for your various applications. And the good thing is, whichever project that comes, you can scale from one processor to the other processor using the same tool chain from TI. Okay, our compiler is called Code Composer Studio, and it is free. Okay. So one example of what we have on the AM62, just to run through overview of the product itself, you can see in the picture itself, there's 4 cores, 4 times ARM Cortex-A53. We have a L2 cache, okay, half a megabyte of level 2 cache. We have the PRUSS, Programmable Real-Time Unit Subsystem. So this is the one that you can do some custom programming, because every application has something special and different. Maybe for printer, you need to have some formatting on the I/O, maybe some FPGA or CPLD replacement, or maybe some communication subsystem. So you can use the PRUSS for your various applications. Okay, we support 16-bit DDR4, LPDDR4 as well. We have a 3D graphics on the top right. We have a 3D graphics processing unit for 8 gigaflops of our graphics processing, display subsystem. Okay, and we also have another MCU there, which is ARM Cortex M4F. Okay, 400 megahertz. So that is your housekeeping MCU. Okay, in a lot of applications, you have a main processor, then you have an MCU externally. So this will be your MCU. You can keep it on the chip itself, and you can power down the entire processor. Just keep this MCU portion power up. Okay, so it's low power during your housekeeping operations. And in terms of the connectivity, we have a whole suite of connection. Okay, like CAN FD. All right, if you're doing automotive, you need CAN bus. CAN FD is there. If you're doing Ethernet, we have 2 gigabit Ethernet ports. You need USB 2.0 high speed. We have as well. Okay, and audio interface, PWM for motor control. So it's almost like everything you can find you need is there for your system. Okay, and we also have security. Now our AM64 series by default will come with security boot, secure boot. Okay, we have a security encryption engine. Okay, accelerators as well. So this will enable you to do high secured applications. If you want to protect your code, protect your application from hacking. Okay. Okay, but processor sometimes is a bit scary. You think that it's very hard to design a processor, the layout, the design, right? And you want to buy module. You buy a SOM, right? System on module. Now, TI, we are innovating in our packaging technology also. We have this new technology called SIP, okay? System in package, all right? What we do is we put the processor die, we put the DDR4 die in the same lead frame, we mold it together. So when we sell to you, it looks like IC chip, but the DDR is already inside. Okay, you'll ask any layout engineer, their nightmare is DDR4 layout. Okay, they do DDR4 layout, they test, whatever they test, simulation they done, the PCB come out, all the noise is there, timing mismatch, then they have to slow down the bus. It doesn't work. Okay, it's very hard to make it good. So what we do, instead of you having to buy a module, you just buy a SIP from TI. Our DDR is already on chip, on the die, on the lead frame itself. So with this optimization, the trace length is very short, managed by TI. You don't have to worry about it. Okay, so the noise is not a problem, EMI is not a problem, timing mismatch is not a problem because TI guarantee you the specs. Plus, TI work with our supply chain to make sure there's no shortages of DDR for you. Okay, you know DDR sometimes we have shortages, but TI we get a die, we have die bank, we can store it in our factory, and then we continue to make it even though in the short moments of shortages for DDRs. And we select a vendor that has longevity. That means the DDR4 supply is for long term. Okay, you know DDR, if you buy it outside, every 18 months they will do a die string and all kind of problems. For TI, we have a long-term plan with our partners to ensure that we can supply you this system in package with DDR on chip. And with that, we simplify your PCB design from 8 layers to 4 layers. All right, so now you can do a 4-layer PCB using this system in package for processor with DDR4, and you don't need to worry about all these layout issues that you have to deal with normally. Okay, so we simplify the design. And just a glimpse of what's going to happen next is that now we put DDR4. Next time we're going to put a PMIC, okay, the power management IC. So it becomes almost really like a full module. Okay, so these are things that TI is continuing to innovate and help you to use our products. Okay. Yep. So this is a comparison of the various series of products that we have, from the AM335X all the way to 62P. Okay. So the key difference you will see that is from the ARM Cortex-A8, we upgraded to Cortex-A53. We added an MCU subsystem, the Cortex-M4 or R5F. Okay. Then a lot more memories. Okay, and all the basic Ethernet ports are all there throughout the whole series of products. And software is important, right? So for your development kit, we will have industrial real-time communication SDK. Okay, so let's say you want to implement some special protocol like EtherCAT. Okay, we will have the communication SDK for you. If some of the chips have RF, right? You want to do some RF simulation, RF testing, we have the Smart RF Studio. Okay, we also engage with open source. We're doing Linux, Yocto, Zephyr. Okay, so TI follow the trend. Whichever thing is more popular in the industry, whatever people are teaching in schools, you are learning or using, we will support the open source community there. And we have a zero-code framework. So for a lot of our microcontrollers, very simple stuffs, you can just do graphical programming. Okay, if you want to know more, you can attend our training tomorrow. How to do graphical programming to get a zero-code. Okay, and the last one at the bottom is AI. How to do AI is a big question, right? So we have Edge AI Studio. We have the tool chain to help you to implement your AI algorithms. All right. So this we not just sell you the chip that do AI, but the software to enable you to implement AI in your system. Okay, changing gears. Let's move on to microcontrollers. Okay, some from high performance. Let's go to low cost. Okay, not very low cost, not very low tier, high performance but low price. Okay, still performance but low price for industrial application, robotic arms, appliances, server power, or energy infrastructure, grid, solar. Okay, so some of you may be familiar with our C2000 DSP. In the old days, we call it C2000 DSP. We have converted that into an MCU. Okay, because C2000, we can make it low power, we integrate the flash, we make it MCU class. And it is the most popular device in the world for motor control and digital power. And with that strength that we have, now we also enter into the industrial communication and edge AI applications with our series of MCUs. We call it application-specific MCU, ASM. So we have low cost from 50 cents. Can you imagine a microcontroller with actually it's a DSP? We can be as low as 50 cents, or we can go as high as 200 megahertz performance, 3-core, 3 CPU times 200 megahertz. Okay, high speed, security module, EtherCAT capable. Okay, so we have from cheaper 50 cents to high performance within this whole series of products. So what can you do with a high performance microcontroller? Like we talk about robotic arm, right? You can do 6 axes in one MCU. Okay, just one MCU alone handle 6 axes. So you think of a robotic hand, right? So many motors needed in one hand. How many MCU you want to put, right? So one MCU handles 6 motors already, for 6 axes for you, right? So that's how we can compress it into a smaller PCBA to fit into a hand for robotic applications. So you can apply that for your robotic arms. You can apply that for your multi-channel, multi-phase digital power, okay, or multi-channels, multi-phase motor control applications as well. And if you don't like C2000, you don't like DSP, you like ARM, we have also. All right. So these are ARM series of products. Okay. So we have ARM Cortex R5F. Okay. So you know ARM has a A series, R series, and M series. M series is the low cost, A is the highest. But there's a few companies, including TI, that we do the R series, which is the real-time performance. So R series is the one that can enable digital power, enable your motor control applications. Okay, so with that, we also have the R series. up to 500 megahertz for the AM261 as well as AM263 products. Okay, so this is an example of what we have on the C2000 series, the F28P65. You can see that we have 2-core DSP. All right, you see a lock over there, means that we can support this feature called lockstep. Okay, so lockstep means that when you want to run a very safe application, okay, such as automotive or some safety feature in a factory environment, you will run 2 processors running the same code at every step. We call it lockstep. And if any of them there's a difference, it triggers your safety shutdown. Okay, so this is required especially for automotive. Okay, they call it the ASIL D standard. They will need this kind of features. So we designed this chip capable for that level of safety. But if you don't need that level of safety, you can use the 2-core independent operation, become a dual-core processor to run your 2 different codes concurrently. All right, and you can see that now we don't just sell you the DSP or the MCU. You can see that we have like 3 ADCs over there, 3.45 mega samples per second each, okay, times 3 of them. A lot of analog features. We have this feature called configurable logic block. Okay, think of it as a CPLD, okay, programmable logic. We absorb your programmable logic into my MCU. Okay, a lot of memory capability, okay, more than 1 meg of flash, a lot of connectivity, CAN interface, okay, Ethernet, EtherCAT as well. Okay, and all this come in a small package of 100 pin, all the way to 256 pins if you require the I/O pins. All right. So with that, this is actually a very powerful device that can cover a lot of your potential applications. And if it's too powerful for you, we definitely have options to scale down for the lower cost applications as well. Okay. So one example of AI, how we are implementing and simplifying your AI application. So in the example on the left, the existing solution I show is that we have a microcontroller to drive a power stage to the motor. Then you will add an MCU to monitor the power lines between the power stage and the motor. Then you collect a lot of information, right, in all the different fault conditions. And then you get your engineer to analyze, do modeling, MATLAB, simulation, and calculate and say that, oh, if this amount trigger, okay, it's a fault. It's going to be a bearing fault. If this amount trigger, it's a power fault. So you will have a lot of analysis, okay, and you spend a lot of time. So that one is human intelligence, okay. But the AI model is that you don't need to hire the engineer to analyze. You just train your data model. You have a lot of data, pump in a lot of data through your AI model, and like this is a good condition. This is a fault condition. Then AI will own self make the logic out of it, the algorithm, and say that, oh, what will trigger a fault, what will not trigger a fault. So it can actually from there do the predictive analysis of when your motor is going to have a failure. Okay? So that's how it's done. And instead of having to put it in a separate MCU, we now build the AI model within our chip, our DSP. So you can just use the AI model within the DSP to do AI detection and of the failure, plus you can control the motor all in one chip. All right? So that's how one of the applications is for the motor fault detection in using AI on our microcontroller class device. Okay, and shifting gears again. Okay, my last topic before I end my session is low-cost MCU. Okay, don't think of TI as Louis Vuitton or Ferrari. We are not an expensive brand. We are a good quality company, big company, but we are not expensive. We can be cheap, and we have products that are low cost. And how we make low-cost product is because we have so many factories, we have so much capacity. You know that economy of scale. The more you make, the cheaper it becomes. That's why TI is competitive in pricing. You want low cost? Come to me, come to Aero, come to Aziz. Let us know what price you see out there against our competitors. We can come to you with low cost. So our low cost as microcontroller, 16 cents. Okay, our MSP M0, okay, which is ARM Cortex M0, 24 megahertz. We're talking about 16 cents. Okay, now you want to know my price of my MCU? Very simple. 1 pin, 1 cent. You want 16 pin? 16 cent. 20 pin? 20 cent. 30 pin? 30 cent. Very simple. If it doesn't fulfill that rule, come to me. Let me get the price for you. Okay? All right? It's very simple to know what's the price of MCU now because honestly, right, ARM Cortex M0, we're talking about less than 50,000 transistor gates. Very small. The die size is so small. My lead frame costs more than my IC. Okay, metal, copper, lead frame costs more than my IC now. That's why 1 pin, 1 cent. Because how many pin determine how much it costs. So the trick to save money, right, you use the smaller package. Okay, don't use the T-SOP and all those big package. Those are expensive. Use a QFN, as less metal as possible, as small as possible. TI, we use less metal, we charge you less also. Okay, because TI don't earn the money, it's the metal costs money. Okay, I know the metal in Indonesia has a lot of copper, but that's not the way to subsidize your government. All right, so you use less copper, you get a cheaper cost. All right, so as cheap as that. But if you want a bit more performance, okay, you want to have 32 megahertz, 80 megahertz, we also have. All right, so it's still low cost, but we give you more performance capability, better ADC, better PWM functions. Even we have a 5-volt tolerant IOs or 5-volt MCU. Okay, we put in high performance analog, op-amps, low power supply, and safety standards, automotive grade as well. And that's the M0 class. And going beyond the M0 class, we have the M33. Okay, M33 will be the performance class, 160 megahertz and above. All right, so we have the MSP M33 for 160 megahertz application, security, ASIL-B automotive standards. Okay, and we're going for higher tier performance products with up to 4 meg of flash. Okay, that is a MSP M33G. And I know there are customers who say that 4 meg not enough. I need 8 meg, 16 meg. Okay, how much you need? No problem. We have this thing called OSPI, octagonal, octal SPI, 8-pin SPI, plus XIP, execute in place. Okay, means I execute the code on the external SPI. You want to put 16 meg, you want to put 120 meg, up to you. You just put it there, I will execute the code from the external SPI. Okay, so with that, we break the limit of how much flash your constraints you have. Okay, if you are within 4 meg, you can use the on-chip. Above 4 meg, use the octal SPI, and we can execute the code in place for you. All right, and with that, yeah, just one more on here. We have a scalable portfolio, M0, as cheap as 8-pin. Okay, 8-pin is not really 8 cents yet. Okay, we're getting close to there, but I think now it's about 12 or cents or so. Okay, for 8 pins. But the mainstream is still 16 pins, all the way to 169 pins or 212 BGA. Okay, so it's scalable from low pin count to high pin count. Scalable from 8 KB flash to 2 megabytes flash. Okay, so we have a whole portfolio of products and depend on the analog features you need. Okay, such as comparators or LCDs or capacitive touch or USB or AI accelerator. Okay, AI accelerator can be done on M0. Okay, ARM Cortex M0 can do AI accelerator. Okay, of course there'll be different levels of AI. Okay, AI can be a very simple AI or can be a very complex AI. So we can do a very simple AI on M0 and we implement that as well. All right. Okay, so with that we have a whole series of products from TI. Okay, and not only that, it also can do pin-to-pin replacement. Okay, so if today you're using any of these devices, 8-pin to 64-pin from the various major vendors, okay, even China vendors, right? We also have pin-to-pin drop-in. Okay, since the shortage 2 years ago, the industry learned our lesson. We all pin-to-pin to each other. We learn to be pin-to-pin. Of course, software you need to migrate. Okay, software you must migrate, but we have migration guide on how to port the code over. But PCB, don't need to change. We pin-to-pin drop-in, voltage, ground, I/O pins, all at the same place. Okay, ADC pins, all at the same place. So you can actually migrate over. In fact, we have tools to help you migrate the code over for some of the simpler ones. Immediately just recompile the code over to this device. Okay, for the more advanced ones, then we have a migration guide on how you can bring your code in. But with that, you can be assured that in the shortages, MCU, you're not stuck. You have a choice. You can choose. Okay, so we have a lot of pin-to-pin options available. All right, and yeah, and so that sums it up that in TI we have 20 cents to 2 gigahertz, high performance AI, mid performance for motor control, digital power, low cost for your general purpose MCU applications. Okay, one pin, 1 cent. Okay, if the price is you don't get the price, from Aero or Aziz, talk to me. I'll make sure you get a prize. All right? Okay, so I think I have about 2 minutes for Q&A before I hand over to the next guy. Anyone, one quick question before I hand over to the next presenter? Anybody at all? Yes?
Hello.
Yes.
Thank you. Maybe I just want to ask, when the TI Texas Instrument provide MCU with Wi-Fi, okay, this I think it will be great. Thank you.
Thank you for your question, and I will get that answer to you in a 30 minutes presentation before lunch. We have a 30-minute presentation on connectivity. We already have Wi-Fi. Wi-Fi 6, system on chip. MCU plus Wi-Fi 6, system on chip. And my young presenter over there, Andrew, will be the one who present on the Wi-Fi later on before lunch. We will get that topic to you. And thank you for the opportunity. Yes, TI, we have Wi-Fi. We have Wi-Fi, Bluetooth, sub 1 gigahertz. We have a lot of RF protocols as well. And I look forward to supporting you on the Wi-Fi. Yeah. Any other questions? One more or two more? This over in the center. Maybe the guy in front first. Yeah. Oh, over there. Okay.
Hello, good morning. Thank you. After you presented about the microprocessor, high-end microcontroller and low-end, how about the IDE that used for development? Is it proprietary or there is a free, open IDE to develop the application?
Okay, yeah, good question.
Thank you.
So the IDE for TI, we have a free IDE. It's called Code Composer Studio. So Code Composer Studio, you just search this on ti.com. You can download for free. You can use it, no code size limit. All the TI products use for free. So compiler now is all free. But if you have a preference, you like Cal, you like IAR, you also can use them. But that one, of course, you must pay the license to Cal or IAR. Yeah. So TI, we support all this, and we also support GCC for open source compilation. Okay. So yes.
Is there any comparison using the open source and the Cal or
yeah.
IDE?
Yeah, we can do compile on Cal and IAR, and open source we do GCC. GCC, yeah. Then the community one, like the MCU one, we do Zephyr. We do Zephyr codes as well. Yeah. Yeah. Thank you. Over there.
Thank you. Does it support the Android OS for the high-end CPU? I mean, I see the Linux OS there. And how about the community? So like ecosystem, something like that on the TI side. Yeah.
Okay. Your question is RTOS on the
Android OS on top of the high-end processor.
RTOS
so is
on
it support?
the high-end processor.
Yeah, I think I see the like Linux, kernel, something like that.
Yeah.
So how about the Android there? So is it supported by TI itself?
Okay.
Yeah.
So for the microcontroller class, like 300 megahertz and below, we do RTOS. We have TI RTOS, we have free RTOS, and then is there another one other than free RTOS? Is there a new one? Sorry, roadmap. Okay. Yeah, so we have TI RTOS and free RTOS today, but we have something else coming up in the roadmap for RTOS. But for the Linux processor class, right, like 1 gigahertz, we provide the Linux kernel, but those processors, we don't provide RTOS drivers. Because at 1 gigahertz, that processor, like ARM Cortex A52, A72, not so suitable to run the RTOS level anymore. So we will run the RTOS on the ARM Cortex R5. Okay, so for example, okay, explain this one. Yeah, here, okay. So you look at the rightmost 62P, right? We don't run the RTOS on the A53. We run the RTOS on R5F. So we don't run the RTOS on the A series. Yeah, so that one we still don't have, and probably we don't. Not many people need that. Yeah, so that one will be constrained there. But if you want to do that, you will still use bare metal. We call it bare metal. That means driver level code, assembly code to do the programming there. Okay. Yeah. Thank you for the question. Okay. Any other questions? Yeah. Sorry. Over the side. First row on the corner. Yeah. Thank you.
Thank you for your talk. I think today microcontrollers are moving to M10, right? And what is the future of the MSP430?
Okay. What's the future of MS430? First thing I must be honest with you is that we have no more roadmap for MSP430. But you know that TI, we sell our products for 30 years, 40 years, no EOL. All right? So we will continue to manufacture and sell MSP430 as long as customers are buying. Okay, and you know our track record. If you look at some part number, like for example, in my head I can think of is F2812. It's like a 30-year-old, 40-year-old DSP from TI. Until today, we are still selling. Okay, so MSP430, we will continue selling. In fact, I'm still shipping a lot of MSP430 to e-meter customers in the region. Cannot say who, but in this region. Okay, we are still selling. So no problem to continue using. If you want to start design, also okay. Our tool chain is still supported, still can develop code, no problem. Just that no more roadmap, no more new device. Yeah. Thank you for your question.